Welcome to Introduction to Cloud Infrastructure and the Azure Architecture and Services Journey. Microsoft Azure supports modern applications across compute storage, networking, and security. Cloud infrastructure is not just a collection of servers, but a global platform that helps teams build quickly, scale safely, and manage resources with confidence. The goal of this learning path is practical understanding for beginners and AZ 900 preparation. By the end, you should recognize the major Azure building blocks and know when each one is useful. Azure architecture and services can be understood as five connected layers. The first layer is core architecture, which covers accounts, subscriptions, resources, regions, and management structure. The second layer is compute, which includes virtual machines, virtual desktops, containers, functions, artificial intelligence, and application hosting. The third layer is networking, which explains how users, applications, branch offices, and data centers connect securely. The fourth layer is storage, which covers storage accounts, subscriptions and service types, migration, and movement tools. The fifth layer is identity and security, which protects access data networks and cloud workloads. These modules build from foundation to operation so you can see how real cloud solutions are assembled. Azure starts with a physical global network of data centers and then organizes services through logical management layers. At the bottom is the global network and regional infrastructure that provides reach and resilience. Above that are regions and availability zones that help place workloads close to users and protect against failures. Resources are the actual services such as virtual machines, storage accounts, databases, and networks. Subscriptions group resources for billing access and limits. Management groups sit above subscriptions and help organizations apply governance at scale. Azure architecture combines physical reliability with logical control so teams can deploy resources consistently and manage them safely. Microsoft Azure is a cloud platform for building, deploying, and managing applications and services through Microsoft's global network. Instead of buying hardware first, organizations can choose services for compute, storage databases, networking, artificial intelligence, and more. Azure supports global scale because workloads can run in regions around the world and connect to users through resilient infrastructure. It also supports pay-as-you-go consumption, so teams can start small and grow when demand increases. Azure provides many services under one platform, so developers, administrators, data teams, and security teams can build reliable solutions without managing every physical component themselves. The journey begins with an Azure account, which represents the person or organization that signs in. From there, they create or use a subscription, which acts as a billing and management boundary for cloud resources. The Azure portal provides a web-based place to create, monitor, and manage services. Once a subscription is available, users can deploy resources such as virtual machines, storage accounts, databases, networks, and applications. Common entry options include free trial student offers and pay-as-you-go. Billing and cost awareness matter from the beginning because cloud resources can create charges when they run. Accounts provide identity, subscriptions provide ownership, and the portal provides a practical management experience. Azure Physical Infrastructure is the worldwide footprint that makes cloud services available near users and resilient to failures. Geographies represent broad market areas that help address data residency and compliance needs. Regions are locations within geographies where Azure services are offered. Availability zones are separate physical locations inside supported regions that help protect applications from data center level failures. Data centers are the facilities that contain servers, networking equipment, power, cooling, and physical security. This infrastructure matters because placement affects latency compliance, resilience, and disaster recovery. Azure hides much of the hardware complexity, but architects still choose regions and zones carefully to meet performance and availability goals. Resources are the deployed cloud services such as compute, storage, databases, and networks. Resource groups are containers that hold related resources for a workload or project. Subscriptions provide billing boundaries, access boundaries, and quota boundaries. Management groups allow organizations to arrange multiple subscriptions into a hierarchy for large-scale governance. Azure policy can enforce rules such as allowed regions required tags or security settings. Locks help protect important resources from accidental deletion or modification. Tags help teams classify resources by owner, cost center, environment, or application. Good management structure makes Azure easier to control, audit, secure, and pay for as environments grow. The Compute Services module explains the choices Azure provides for running workloads. Compute is the processing power that runs applications, jobs, desktops, automation, artificial intelligence, and edge systems. Virtual machines offer the most operating system control and are useful when teams need infrastructure as a service. Azure Virtual Desktop delivers remote Windows desktops and apps from the cloud. Containers package applications for portability and consistent deployment. Azure Functions runs small pieces of code in response to events without managing servers. AI and IoT services support intelligent applications and connected edge devices. App hosting options provide managed platforms for web applications and APIs. Azure offers multiple compute models, so architects can choose the right balance of control, scale, speed, and operational responsibility. Azure virtual machines provide flexible infrastructure when teams need full control of the operating system and software stack. A virtual machine is a software-based server running in Azure with CPU, memory storage, networking, and an operating system. You can choose Windows or Linux images and configure size, disk, network access, and security. VMs are useful for legacy applications, custom software development, testing domain services, and workloads that need special configuration. They are considered infrastructure as a service because the customer manages the operating system, patches software, and many security settings. Azure provides features such as availability sets, zones, managed disks, backups, and scale sets to improve resilience and scaling. The main point is that VMs are powerful when control matters, but they require more management than fully managed services. Azure Virtual Desktop delivers Windows desktops and applications from Azure to users on many devices. The desktop experience runs in the cloud while users connect securely from laptops, tablets, phones, or thin clients. This model helps organizations support remote work, bring your own device scenarios, and centralized desktop management. It supports secure access, multi-session capability, and work from almost anywhere. Administrators can publish full desktops or individual applications and manage images, profiles, and access centrally. Azure Virtual Desktop can reduce the need to maintain physical desktop hardware in every location while still giving users a familiar Windows experience. It also integrates with identity security and networking controls. Azure Virtual Desktop is a managed way to provide flexible remote productivity while keeping corporate apps and data under control. Containers package application code and dependencies so the application can run consistently across environments. That image can run as container instances for simple workloads or on Kubernetes when orchestration is needed. Containers are portable because they include what the application needs while sharing the host operating system kernel. They start quickly and support repeatable deployment pipelines. Azure Container Instances offers a simple way to run containers without managing servers. Azure Kubernetes Service helps manage large groups of containers with scheduling, scaling, service discovery, and rolling updates. The main point is that containers improve deployment speed, consistency, and portability, especially for microservices and modern cloud-native applications. Azure Functions is a serverless compute service for running small pieces of code on demand. A function responds to a trigger such as an HTTP request timer queue message event or storage change. The function executes business logic and can produce outputs such as database updates, messages, files, or API responses. Serverless means developers focus on code while Azure handles much of the infrastructure scaling and availability. Functions are event-driven, so they are ideal for automation, lightweight APIs, background processing, data transformation, and glue logic between services. They can scale automatically when events increase and cost is often based on execution consumption. Azure Functions is best when work is discrete event-based and does not require managing a full server or long-running application host. Azure AI services provide ready-made capabilities for language vision, speech decision support, and generative experiences. Azure Machine Learning helps teams build, train, deploy, and monitor custom models. IoT Hub connects and manages devices that send telemetry from the real world. Edge services allow workloads or intelligence to run closer to devices where latency, connectivity, or bandwidth matters. The pattern is simple: sense, predict, and act. Devices sense conditions, data flows through IoT, and machine learning predicts outcomes. Then applications and operators act on insights. Azure supports intelligent solutions that can run in the cloud, at the edge, or across both, depending on where data is created, and decisions must happen. Azure offers several ways to host applications, and each option fits a different operational need. Azure App Service is a managed platform for web apps, APIs, and mobile backends, where teams want less infrastructure management. Containers are useful when applications need portability and consistent packaging across environments. Virtual machines provide maximum control over the operating system and custom software, but require more administration. Azure Functions is ideal for event-driven logic and serverless execution. The decision often comes down to the trade-off between control and convenience. More control often means more responsibility for patching, scaling, and monitoring. More managed options reduce infrastructure work but may limit low-level customization. Choose hosting based on application pattern, portability needs, scaling behavior, and the amount of platform management the team wants Azure to handle. The networking module explains how Azure connects users, applications, cloud resources, and on-premises environments. Networking is the secure path between everything that must communicate. Azure Virtual Network creates private network space in Azure and allows segmentation with subnets. VPN connects remote users or branch offices to Azure through encrypted tunnels over the internet. ExpressRoute provides a private, dedicated connection for predictable performance and stronger privacy than normal internet routes. Azure DNS translates readable names into addresses so services can be found. Networking also supports security through private endpoints, gateways, route tables, firewalls, and network security groups. Azure networking is not only about connectivity, it is also about isolation reliability, name resolution, hybrid access, and protecting traffic between systems. Azure Virtual Network, or VNet, is a private network foundation for Azure resources. A VNet lets resources such as virtual machines, databases, app services, and private endpoints communicate securely using private IP addressing. Subnets divide the VNet into smaller segments, such as web app and data tiers. Segmentation helps apply different security rules and routing for each layer of an application. Private endpoints allow supported Azure services to be reached through private network addresses instead of public internet paths. VNets can connect to each other through peering and can connect to on-premises networks through VPN or ExpressRoute. A VNet gives architects control over address space, isolation, traffic flow, and secure access so workloads can be designed like enterprise networks in the cloud. Azure VPN provides encrypted connectivity between Azure and users or on-premises locations over the public internet. Point-to-site VPN connects an individual remote user device to an Azure virtual network. Site-to-site VPN connects an entire branch office or data center network to Azure through a VPN gateway. The encrypted tunnel protects traffic as it travels across the internet. VPN is useful for hybrid connectivity development environments, small offices, remote administration, and scenarios where private dedicated circuits are not required. It is generally faster to set up than ExpressRoute, but performance depends on internet conditions and gateway capacity. VPN extends private network access into Azure in a secure, flexible, and cost-conscious way. Azure ExpressRoute provides a private dedicated connection between an enterprise network and Azure. Unlike VPN traffic, does not rely on the public internet path. Organizations use connectivity providers or exchange locations to establish private circuits into Microsoft Cloud services. This approach can provide more predictable performance, lower latency, higher throughput, and stronger privacy for critical workloads. ExpressRoute is valuable for large migrations, hybrid applications, regulatory environments, data-intensive systems, and enterprise connectivity between data centers and Azure regions. This avoids the variability and exposure of public internet connectivity. Also note that ExpressRoute is often designed with redundancy and can be combined with VPN as a backup. ExpressRoute is the preferred option when hybrid network performance, reliability, and privacy are major requirements. Azure DNS hosts DNS zones and records, so applications can be reached through friendly domain names. DNS name resolution translates names like example.com into IP addresses that services and users can connect to. A DNS zone contains records such as a CNAME, MXTXT, and other entries that define how names resolve. Azure DNS can host public DNS zones for internet-facing domains and private DNS zones for internal name resolution inside virtual networks. This helps cloud resources discover each other without hard-coding addresses. A name resolves through a DNS zone to an address record and then to a cloud service. DNS is a basic but essential part of cloud architecture because reliable naming makes services easier to find, manage, and secure. The Storage Services module explains how Azure stores data durably and moves it when needed. Storage is the persistent foundation for files, objects, messages, tables, disks, backups, and application data. Storage accounts act as top-level containers for services and settings. Redundancy options copy data within data centers across zones or across regions to improve durability and availability. Azure storage services include blob storage for unstructured data, files for shared file access, queues for messaging, and tables for key value data. Migration tools help move databases, files, and workloads into Azure using online or offline paths. File movement tools support interactive bulk, secure, or disconnected transfer scenarios. Azure Storage is designed for durability, scale, security, and many different data patterns. An Azure Storage account is the top-level container that groups storage services and settings together. When a team creates a storage account, it receives a unique namespace used to access services. From one account, they can use blob storage for objects, files for shared file shares, queues for messaging, tables for key value data, and disks for virtual machines. The account controls important settings such as replication performance, tier access, security network rules, and encryption. Storage accounts can support different workload patterns such as application files, backups, logs, media archives, and data lake content. All of these services connect back to one managed storage boundary. The storage account is where Azure storage begins because it defines how data is accessed, protected, organized, and built. Azure Storage Redundancy protects data by creating copies in one or more physical locations. Locally redundant storage, or LRS, keeps copies within a single data center and is the simplest option. Zone redundant storage, or ZRS, stores copies across availability zones within a supported region, which helps protect against data center failure. Geo-redundant storage, or GRS, copies data to a paired secondary region for regional disaster protection. Geozone redundant storage, or GZRS, combines zone protection in the primary region with a copy to another region. Choosing redundancy depends on cost, availability, recovery requirements, and compliance. Higher redundancy generally improves resilience, but may increase cost and design complexity. Redundancy is a deliberate architecture choice for protecting data from hardware data center or regional failures. Azure Storage includes multiple service types for different data and messaging patterns. Blob storage is designed for unstructured data such as images, videos, documents, backups, logs, and data lake files. Azure Files provides managed file shares that can be accessed by SMB or NFS depending on configuration and is useful for lift and shift applications, shared tools, and user content. Queue storage provides simple messaging between application components so work can be decoupled and processed asynchronously. Table storage offers a NoSQL key value style store for large amounts of structured non-relational data. Each service has a different access pattern and use case. Storage design starts with understanding the data shape and workload behavior rather than choosing one service for every requirement. Azure provides different migration options depending on data size, connection speed, downtime tolerance, and workload type. Migration usually follows either an online or offline path. Online migration moves data, while systems stay connected through network paths and can support synchronization to reduce downtime. This approach fits smaller data sizes, fast networks, and workloads that need continuous access. Offline migration uses appliances or devices when data volumes are too large for practical network transfer or when connectivity is limited. Database migration tools help move database workloads while preserving structure and minimizing disruption. Appliances can help ship large datasets physically to Azure. Migration is often more than copying data because teams also need to sync, modernize, and improve workloads along the way. The goal is to move workloads safely, then improve them with Azure services where appropriate. Azure File Movement options help teams move data between local systems, edge devices, and cloud storage. Copy is a command line tool for high-speed bulk copy operations to and from Azure Storage. Storage Explorer provides a graphical interface for browsing and managing blobs, files, queues, and tables. SMB file access supports traditional file sharing patterns when applications and users need mounted shares. Azure Databox supports offline movement for large datasets by using secure physical appliances. Edge devices can collect or stage data near where it is created before sending it to cloud storage. These options support bulk, interactive, offline, and secure transfer patterns. The right movement tool depends on scale, user experience, network constraints, security requirements, and whether the transfer can happen online or must use physical shipment. The Identity and Security module explains how Azure protects access resources, data networks, and workloads. Security in Azure begins with identity because every action should be tied to a verified user service or application. Directory services centralize users, groups, devices, and applications. Authentication methods confirm who is signing in. External identities allow partners, customers, and guests to collaborate securely. Conditional access evaluates signals such as user, device, location, and risk before allowing access. Role-based access control grants permissions at the right scope using least privilege. Zero trust assumes no request is automatically safe. Defense in-depth layers controls across physical identity, perimeter, network, compute application, and data. Encryption, key management, and Defender for cloud protect information and workloads. The main lesson is that cloud security is continuous, layered, and identity-centered. Azure Directory Services organize identities and resources so people, applications, and devices can be managed centrally. Microsoft Entra ID, formerly Azure Active Directory, is the cloud identity service behind many Azure and Microsoft 365 sign-ins. A tenant represents an organization dedicated directory instance. Within the tenant, administrators manage users, groups, applications, and devices. Users represent people who sign in. Groups simplify access assignment by collecting users with similar needs. Applications register service identities or enterprise apps that need authentication. Devices can be joined or registered to help enforce access policies. Directory services are important because they provide the trusted identity foundation for authentication, authorization, auditing, and collaboration. Before resources can be protected effectively, organizations need a central place to define who and what is allowed to interact with them. Authentication methods verify that a user or service is who they claim to be. The sign-in process starts when a user presents credentials. Passwords are common but vulnerable when used alone. Multi-factor authentication adds another verification step, such as a phone app code prompt or hardware token. Single sign-on lets a verified identity access multiple applications without repeated sign-ins, which improves user experience and reduces password fatigue. Passwordless methods such as biometric security keys or app-based authentication can improve security and convenience by reducing reliance on shared secrets. Organizations choose methods to balance usability, risk, and compliance. The goal is verified identity. Stronger authentication helps prevent unauthorized access while still supporting productive work. Azure external identities allow organizations to work securely with people outside the company. Not every user who needs access is a full employee. Partners, suppliers, consultants, customers, and guests may need controlled access to applications or data. Business to business or B2B collaboration allows external users to access shared resources while still being governed by policies. Business to customer or B2C scenarios support customer facing identity experiences. Guest access enables temporary or limited collaboration. Federation allows trust with other identity providers so users can sign in with existing credentials. External users are brought in through controlled access rather than being treated like internal users. External identity features support collaboration while preserving governance, auditing, and access controls. Conditional access turns identity signals into access decisions. Azure evaluates conditions such as who the user is, what device they're using, where the sign-in comes from, and whether risk is detected. A policy then determines the response. The response might allow access block access or require multi-factor authentication before continuing. This is powerful because not all sign-ins carry the same risk. A trusted user on a compliant device from a normal location may be allowed, while an unusual risky sign-in may require extra proof or be blocked. Conditional access is a key part of Zero Trust because it checks context continuously instead of assuming that a password alone is enough. Access should adapt to real-time conditions and organizational policy. Azure Role-Based Access Control, or RBAC, helps grant the right permissions to the right identities at the right scope. An access assignment has three parts. A security principal is the user group service principal or managed identity receiving access. A role definition describes allowed actions such as reader, contributor, owner, or a custom role. A scope defines where the role applies, such as management group, subscription resource group, or individual resource. Least privilege matters because users should receive only the permissions needed to do their job. Assigning roles to groups instead of individuals can simplify administration. Scoping access tightly reduces accidental or malicious impact. RBAC is how Azure authorizes management actions, and it should be designed carefully to support security, accountability, and operational efficiency. Zero trust means every access request is checked continuously, instead of being trusted simply because it comes from inside a network. Verify explicitly means use all available signals such as identity device, health location, data, sensitivity, and risk. Use least privilege means grant only the access needed for the task and limit standing permissions. Assume breach means design as though attackers may already be present and use segmentation monitoring, encryption, and rapid response. Users, devices, apps, and data all interact through verified paths. This reinforces that zero trust is not one product. It is a security model applied across identities, endpoints, networks, applications, and data. Modern cloud security relies on continuous verification and limited trust. Defense in depth uses multiple layers of protection, so one control failure does not expose everything. Physical security protects data centers and hardware. Identity controls verify user services and devices. Perimeter controls reduce exposure at the boundary. Network controls segment and filter traffic. Compute controls harden servers, containers, and platforms. Application controls protect code configuration and runtime behavior. Data controls protect the most valuable information through access rules encryption, backup, and monitoring. The idea is similar to a castle with several gates and walls rather than one lock on the front door. In Azure, this approach combines built-in platform protections with customer-configured controls. Strong security is layered, so prevention, detection, and response work together. Encryption and key management protect data at rest and in transit while controlling access to keys and secrets. Data at rest includes stored information on disks, databases, files, and storage services. Data in transit includes information moving across networks between users, applications, and services. Azure provides encryption capabilities for many services by default and also allows organizations to manage customer-controlled keys when needed. Azure Key Vault is used to store and protect keys, secrets, and certificates. Keys can control encryption operations while secrets hold sensitive values such as passwords, connections, strings, or tokens. Certificates support trusted communication and identity scenarios. Good key management includes access control, rotation monitoring, and separation of duties. Encryption protects information, but the real security depends on managing keys and secrets carefully. Microsoft Defender for Cloud helps improve security posture, detect threats, and prioritize actions across cloud resources. On one side are posture management views that show secure score, recommendations, and coverage status. Secure score helps teams understand how well resources align with security best practices. Recommendations guide administrators toward actions such as enabling protections, tightening access, or fixing risky configurations. Defender can also provide threat detection alerts for workloads such as servers, containers, apps, and data services. At the center is coordinated protection across resources. Security teams need both preventive guidance and active detection. Defender for Cloud gives visibility and prioritized remediation so organizations can reduce risk across Azure hybrid and multi-cloud environments. You can map the Azure services in this course into a simple architecture. Start with the business need, then identify compute choices such as virtual machines, containers, functions, or app services. Add the storage patterns such as blobs, files, queues, tables, or disks. Add networking using VNet, subnets, VPN, ExpressRoute, DNS, and private endpoints where appropriate. Add identity controls such as Microsoft Entra ID, RBAC conditional access, and authentication methods. Add security controls such as zero trust principles, defense in-depth encryption, and Defender for Cloud. You should think in connected patterns rather than isolated services. Cloud architecture is a design practice where services are selected and combined to meet performance, reliability, security cost, and operational goals. Azure Cloud Infrastructure is a set of global services and management capabilities that help teams build modern solutions without owning every physical component. You have explored the major foundations, including architecture, compute, networking, storage, identity, and security. You should now understand how regions, zones, subscriptions, resource groups, and management groups form the structure. You should also recognize when to choose virtual machines, desktops, containers, functions, app hosting, VNets, VPN Express, root DNS storage accounts, redundancy migration tools, and security controls. The next step is practice. You should open the portal, create a small resource group, review cost settings, deploy a simple service, and inspect access controls. Good cloud design balances scale, reliability, security, cost, and simplicity for real business outcomes. Thank you for watching. See you in the next video.